So now we're going to move on to start our work with polynomials again, and we're going to begin with multiplying monomials. So a monomial is a polynomial with only one term. We're going to apply exponent rules to do this multiplication. So example 1, determine the product of 3x times 2. So one dimension is 3x. Our other dimension is 2. Product is really just finding the area of the rectangle defined by the two numbers or two quantities. So if I make a rectangle that's 3x and 2, and I fill in the space with tiles, I end up getting an area of 6x tiles. And when you set up your dimensions, you have to fill in with the correct tiles. I needed a tile here that was x long and 1 tall. That's why I picked the X tile. And a quick check is after you set up your area, all of your split lines or lines in between tiles should be consistent with no breaks. When we calculate this area, 1, 2, 3, 4, 5, 6, we have 6x. So the product of 3x and 2 is 6x. Determine the product of 3x times 2x. So now one of our dimensions is 3x. Our other dimension is 2x. I'm going to find the area defined by those two numbers by filling in the space. Now I need tiles that are x wide and x tall, so that's a large x squared tile. I fill in the space, and it takes 6x squareds to fill the space. So what is 3x times negative 2? So one of our dimensions is 3x, and our other dimension is negative 2. Now we have to think about signs here. A positive and a negative becomes a negative, and a negative and a positive becomes a negative when we multiply them together. What this means in the context of the tiles is if we have different colored tiles, a red and a blue, or a blue and a red, defining an area, we have to fill it in with a negative tile, a blue tile. So when I come over here, I have a positive x and a negative 1. Different colors, a red and a blue, I have to fill it in with a blue. Same thing here. Red, blue is blue. So I fill in all the spaces with blue tiles, and when I count them up, I end up with negative 6x. So the area created by those two numbers is negative 6x. Determine the product of negative 3x times negative 2x. So now one dimension is negative 3x. The other dimension is negative 2x. I need to remember that a negative times a negative becomes a positive. And again, what that means in context of the tiles is that same color is red, different color is blue. So two blue tiles make a red tile. So a blue x by a blue x is a red x squared. And so on, I can fill in all the area, and when I get that, I end up with positive 6x squareds to fill the area. So how could we do this without using the algebra tiles to model? So number 1, we multiply the number coefficients. So in 2x times 5x, I multiply the 2 times the 5 to get 10. Step 2 is we're going to multiply the variables with the same base. And the rule for multiplying variables with the same base is keep the base and add the exponents. X to the 1 times x to the 1, 1 plus 1 gives me 2, so the answer is 10x squared. So 2 times x times 5 times x is 10 times x squared, or 10x squared. A times 7a squared equals 7, 1 times 7. A cubed, a to the 1 times a squared, 1 plus 2 is 3. So 1a times 7a squared, 1 times 7 is 7, a1 times a2 is a3. Added the exponents. So determine the product of negative 2a times 3a squared. Well, negative 2 times 3 is negative 6. And a1 times a2 is a3. added the exponents. Negative 2b times 7, negative 14b. Negative 2 times 7 is negative 14, and b multiplies by b to the 0 or 1 or no b, so it just stays the same. 3xy times 2x squared. 3 times 2 is 6. x1 times x2 is x3, and y stays the same. Negative 3b times 2x squared. Negative 6, negative 3 times 2, x squared, and then b. Negative 5y times negative 2x squared y squared. Positive 10, x squared, y to the 1 times y to the 2, y to the 3. Now let's move on to dividing monomials. So we're going to divide the number coefficients, and we're going to use the law for dividing powers, which means we're going to subtract exponents for the variable part. So 6x cubed divided by 2x. 6 divided by 2 is 3, and for the variable we're going to do 3 minus 1 in our exponent to give us 3x squared. A cubed divided by 2a squared. 1 divided by 2 doesn't work, because remember, whenever a coefficient is missing, it's 1, so I write it as 1/2. A fraction is a division waiting to happen, or one that we couldn't do. A3 divided by A2, I subtract exponents, 3 minus 2, so I get 1/2 A, or A over 2. 20x to the 5th divided by negative 4x. 20 divided by negative 4 is negative 5. X to the 5 divided by x to the 1. 5 subtract 1 is 4. Negative 36a squared divided by negative 9a squared. Well, negative 36 divided by negative 9 is positive 4. A to the 2 divided by a to the 2. 2 minus 2 is 0. But remember our law for exponents. Any base to the exponent 0 is 1. So this is 4 times 1, which is 4. 100 y to the 8th divided by 10 y to the 5. 100 divided by 10 is 10. 8 subtract 5 is 3. 25 x to the 5 y to the 4 divided by negative 5 x y to the 4. 25 divided by negative 5 is negative 5. X to the 5 divided by x to the 1. 5 minus 1 is 4. y4 divided by y4 is y to the 0 or 1. There are no more y's left. 2s5t2 divided by 10s squared t squared. So 2 divided by 10, I'm just going to hold on to that for a second because it's a fraction and the division doesn't work nicely, so I can't do it right away. 5 minus 2 leaves a power of 3 for my s's, and 2 minus 2 is 0. 2/10 and lowest term is 1/5. 2 divided by 2 is 1. 10 divided by 2 is 5. S3, and of course t to the 0 is 1. We don't need it there anymore. And finally, negative 8y cubed divided by 8y to the 5th. Negative 8 divided by 8 is negative 1. y3 divided by y5 is 3 minus 5. I end up with negative 1y to the negative 2 because I'm working with integers here. 3 subtract 5 is negative 2.